Okay. So remember, we're recording this. So if you have a question, speak loud. Okay? We're clear? Okay. So look in your notes and see that problem. It's in the one of the problems we did for your if-else. Okay. So in the quiz that we had, it was only this part. There was a rod resting on a wall, and then it gives you the magnitude of the force. So the question here was, was the force vector, FAB? Okay? So we're going to do that, plus find the moment about point O, which is part of the new material, and then find the projection of the force along line OA. Okay? So we're reviewing a lot of things just with this one problem. So let's see about the first part. What is the force along AB? And it gives you the magnitude of the force. And so what I've done here is give you the coordinates for point A and point B. Why do I need to give you that? Because?
The position vector.
The position vector, right. So if the force goes from A to B, do I look for the position vector from A to B or from B to A? The position vector from A to B. Okay. So is it B minus A or A minus B? B minus A. So it would be 0 minus 4I plus what? 2 minus 0 J plus 4 minus 0 K. Okay, so what I have is minus 4I plus 2J plus 4K. This is the position vector. Sorry about that. Okay? For my own sake, I'm going to rewrite it on the board so I don't forget. Okay? So I have So I have, this is force AB, it was equal to 100, what, newtons or pounds? Pounds. Okay, so I have my position vector, which was minus 4I plus 2J plus 4K. Now I need to do what? The unit vector in that same direction, and that would be what? Minus 4I plus 2J plus 4K divided by what? The magnitude, which would be what? Minus 4 squared plus 2 squared plus 4 squared. Get your calculators out so you give me that information, please. So this would be 6. So what would be the unit vector? Minus 4 over 6I plus 2 over 6. I'm not making shortcuts so that you know where you're at. Okay, so now the force vector AB would be what? The magnitude of the vector multiplied times the unit vector in the direction AB, right? So what I have here is 100, and then of course this here does not have units, but the force vector will have units. So we have 100 times minus 4, 6i plus 2, 6j plus 4, 6k, and this is pounds. Okay? So what is the force vector in the direction? Let's give me now the actual number. 10 times 4 divided by 6. 100 times 4 divided by 6. Calculators, everybody calculators out. 60? 60? 66.7 I plus plus and this is pounds. Okay? Now for my sake, I'm going to write down that number too. Okay? So now we have responded to the first question. So the force vector AB is minus 66.7I plus 33.3J plus 66.7K, and this is pounds. Let's double check if we're correct or not. Because then the magnitude of that vector has to be what? 100, right? So how do I do that? How do I check that? Would be what? 66.7 squared plus 33.3 squared plus 66.7 squared. How much is that? Do the calculation. Everybody, calculators out. Everybody. Okay, calculators out. Okay, so 100.03, right? The rounding up. So we're okay. Okay, so we double checked. So the second question was what? Calculate the moment about point O. Okay, so the second question was to calculate. Now this is, we're going to get a vector in this case. So what is it that I need to calculate the moment about point O? Would be what? Not a distance. Remember, this is 3D. So I need either, would be R0A cross product FAB or R0B cross product of FAB. So whenever we talked last time, we mentioned that the cross product, to calculate the moment, what you do is you have your force vector and then a position vector along any line. So along any line, along the force. Okay? So you should get this same result, regardless of what position vector I get from 0, which is the point where I'm calculating the moment, along the line of the force. Is that clear? Okay. So that means here let's do A, because we have here. So my R0A was what? What is the vector? 4I plus 0j plus 0k. Now these are in foot. Remember, the units are always important. Okay? So how do I calculate that moment? Remember, we had to write I, j, and k. And then here would be 4, 0, 0, and then on the bottom one, what is it? 6.7 33.3 and 66.7. Remember that? Yes or no? Okay. So what I have is, remember, you have to put, here's your I, and then you put a minus in front of the J right away so you don't forget. Okay? So what do I have here? I, and it's what? Let me use the highlighter. So what you do is, it's the I, and then I look at this cross product. So it would be what? And I'm not going to make shortcuts so that whenever you go back to the video, you know where the numbers come from, okay? So it would be what? 0 times 66.7 minus 0 times 33.3, okay? So that's the first part. So for the second part, oops, I didn't mean to do that. Let me rewrite that again. So now, it would be what? Here you have this part and this part. It would be what? Minus J, and it would be what? So it would be 4 times 66.7 minus 0 minus 66.7, correct? Okay, now, I guess I need to change the color of the highlighter. Let me put it in green. So then finally for K, this is what I have. So it would be what? 4 times 33.3 minus 0 minus 66.7. So what is this equal to? So it would be what? I times 0 minus J, and what would that be? How much?
Negative 267.
267 plus K, and it would be what? 133. Okay? So then the moment about point 0 would be, let's put it in the same notation we've been using, minus 267J plus 133K. And the units of the moment would be what? Pounds times foot. No? Not per foot. Times foot. Okay? So for my sake, so I don't forget, I'm going to write it down this way. Okay? So the moment about point 0 would be 0 I minus 267J plus 133K. What is the magnitude of that moment? Okay, so the magnitude of that moment, and let me go to the next, no, continue recording. I guess I ran out of, so the magnitude of that moment would be what? So we have, would be 0 squared plus minus 267 squared plus 133 squared. And you said it was what?
298.
290?
298.
298. Okay? So what was the other question? The last question was what? You have my force and the force vector, and the question was, what was the magnitude of the projection along that line 0A? Okay? Right? So I have my force vector A, B, and my force vector was minus 66.7 I plus 33.3 J plus 66.7 K, and this was pounds. Okay? So if I want that projection along this 0A, what do I need? I need this, right? Because for projections, different than for vectors, remember the first thing we did was we had a unit vector that goes in the direction of the force multiplied times that magnitude of the force gives me the force vector. But now we're looking for projections. So it's not multiplication, it's what? The dot product. Okay? So this would have to be what? Force AB dot U0A, right? And this would give me the force along that line, but it's a magnitude, it's a scalar amount. Okay? So, the first thing I have to do is then find the position vector from 0 to A, which is what? These are my coordinates here. So it would be just 4I. Right? And this is a position vector and the units are feet. So what is the unit vector in the direction of 0A? Would be what? So let me not make any shortcuts again. So what is this? What is the magnitude of 4 squared? So it would be 1I, right? Plus 0 plus 0. So this is the unit vector in the direction of A. And I mean, I should have known that without having to calculate because it's a long x-axis, right? So it's 1I. Okay? So then when I look at the dot product, okay, so the dot product would be what? You have this is the dot product. What was the equation for the dot product? If I have, okay. Let me, okay, so it would be what? Here's my F AB and here's my unit vector. So it would be what? Minus 66.7 times 1 plus 33.3 times 0 plus 66.7 times 0. So is it 1 positive? Okay. So what is then the magnitude of this? It's a, what is it? Huh? What is the magnitude? How much? Well, I have this is magnitude, so 66.7, and it's what? Pounds. Okay? The absolute value, yeah. Now, the reason why it's negative is because it goes in the opposite direction. If we had because I said from 0 to A, but the vector goes from A to B, right? So the projection is opposite, but the magnitude is 66.7. Okay? And I think I'm going to leave it as complicated as that and leave it at that. Okay? So just the absolute value. Okay? So
we can expect problems like that on the exam for
yes.
one question, but it's multiple.
Well, but not the moment. But this part here. Yes. Yeah. So this is the type of a question that you can expect. Yes.
To find the angle, that's when we use the equation of the magnitude under the dot point.
Okay, so someone has the equation for the angle. If we want to find the angle between the two, how is it? It was what? Cosine of theta. So it was the magnitude of F times the magnitude, well, this is magnitude is 1, right, equals, times the cosine of theta is what? 66.7. And then in this case, then you can find the cosine of theta. Okay? Yes? Okay, so if you want to find the parallel one, how is that? Because first is the parallel one, right? So the parallel one, and let me see if I have a blank slide here. I don't have. Yeah, and I don't want to end the presentation. So once you have this magnitude, you go back to what we learned before, right? So the force vector would be this magnitude times the unit vector along this direction, right? So it would be the force A0, then you have what? 66.7, okay? And then you have the negative here times, it's I, 1I, okay, minus 66.7 I. That's the parallel one. Because what we did is once you have the same concept as before. If you have the magnitude and the unit vector that goes along the force vector, you multiply it and gives you the force vector. Okay? So now, how do you find the perpendicular one? Well, the perpendicular one, if you have the parallel one plus the perpendicular one, should give you the force vector. Right? Yes. Well, what happens is that if you look in terms of vector, then is vector plus the vector equals the vector, right? But here is magnitude. So that's why in your notes, that's why you have to be so careful if you look at the book, because the notation that they use for vector is using italics, and the notation they use for magnitude is in bold. Okay? So whenever you're talking about the magnitude, it's like this, and that's why when I write, I put the little arrow or bar on top so that you know that it's the vector. Okay? Any other question? We're doing good. Yes, no?
Can you give an example of the predictor?
So I'm trying to find a spot here in the notes. Okay, so what is the magnitude of the parallel one? Okay, what is the magnitude of the force vector? 100. So then, let me look for a space. I'm trying to find. So 66.7 squared plus the perpendicular one squared equals 100 squared. So what is the magnitude of the perpendicular one? 100 squared minus 66.7 squared, what is that? 74.5 pounds. Okay? Questions? Ask me, ask me. I love questions. Yes?
Excuse me, where did you get the 100 from?
The what?
100.
It was given. It was the magnitude of the force vector. This force, see, this was given. Okay? Okay? And then you found the perpendicular and the parallel. Questions? Okay, so